Alright, so let's start the class today. So first thing first, we are still in matrices and this is such a monstrous chapter. It has a lot of things. I mean monstrous as in it is vast. It has a lot of things to learn and you'll experience that. But before I proceed, a quick question to you all. Whatever we have learned with respect to matrices, are we clear about the basic operations with matrices? Addition, adding matrices, subtracting, multiplying matrices. Are we all clear? Okay.
Yes, sir.
Okay.
Yes, sir.
Why I'm asking that is primarily because the concept that we're going to learn is going to revolve quite a lot around that. Okay. So it'll probably require us to do more practice with the concept that we have learned, be it with respect to geometrics, be it with respect to identity metrics and those stuffs. I'm assuming that you guys are keeping pace with whatever we have learned. If not, make sure that you keep on revising. However, when I'm teaching something new, I'll make sure that I touch upon those things. I'll not just blindly assume that everybody knows and I'll skim through it. I'll make sure that I do that so that we understand that. Okay. So let's quickly look at the concept that we have still remaining in this chapter or this unit. Those are understanding how do we represent system of equations with matrices. That is one. Inverse matrix. What is inverse matrix? What is the introduction of that? How do we find out inverse matrix of any given matrix? How do we use that for dealing with matrix equations? And a very important concept that we come across is determinant. And then we'll find out inverse of matrix, and then and we'll use those concepts for even solving system of equations. So let me just give you a quick glimpse of that before I get started. Let's say if we have a system of equation like 2x plus 3y equal to 8, and then one equation, the system equation like this, and then x minus 2y equal to 7. I have these two equations. We know that how do we solve the linear equations, right? You have two equations, two variables, you'll be able to solve it following the basic algebra that we all know, right? Matrices also help you solve the system of equations using matrices. So that will be the last thing that we learn in this chapter. But before that, let's kind of focus on the other concepts that we need to be aware of before we come to this point where we find one more alternate way of solving system of equations. I mean, a system of equation like this, I know that you guys can solve in two ways, right? One is by solving it through algebra. The second is by plotting this on a coordinate plane and finding out where it intersects, and the coordinates of that point will be the solution for x and y, correct? Yes or no? Okay. So I'm just repeating. So if you have two linear equations, you know that you can solve it using algebra, where you'll use elimination technique or substitution method for solving for x and y. Here we have two equations, two variables, so that's how we can solve it. If we have three equations, three variables, similar method we will use for solving it. And other method is you plot these two lines. This is a linear equation, this is another linear equation. You plot these two lines wherever they intersect, find out the x and y coordinate of that. That will give you the solution for x and y. So there are two methods. Third method is using matrices, and that also we will learn today. Not today, probably. I'm kind of believing that we might need one more class because there are a lot of things to cover still. So first thing first, any matrix that we talk about, let's say if I'm talking about a matrix A, and which is 2 by 2 matrix, that means I'm talking about matrix having A, comma B, C, comma D. 2 by 2 meaning 2 rows and 2 columns. That's the basic definition. If I'm talking about 3 by 3, I will expand that. I will have 3 columns, let's say E, F, and I'll have 3 rows, G, H, I. So it's a 3 by 3 matrix. So this is a basic outline of the matrix, right? This is how you define the matrices. So similarly, if it becomes 3 by 2, that means I'm talking about 3 rows and 2 columns. So 3 rows and 2 columns, this column disappears. So this is the basic dimension of a matrix. Now, what do we mean by inverse of a matrix? So the basic concept, first thing that I want to start with is, I will not go to inverse first. Let's talk about a determinant of a matrix. If I have matrix A, and which is, let's say, and for the sake of simplicity, I will focus on a 2 by 2 matrix. That pretty much covers the boundary of what you guys need to know. So if I have matrix A, which is 2 by 2 matrix, meaning 2 rows and 2 columns, what do we mean by determinant of a matrix? Any definition that you guys are aware of? Anything that rings the bell, or any simple way how you can relate to it? What do you mean by determinant of a matrix? Any idea? Any basic simple definition? No idea? Okay, so if you're talking about matrix, it's nothing but an array of numbers. A determinant of a matrix, again there's no formal definition of that, but the way you will represent that is, a determinant of a matrix gives you a scalar quantity to define the magnitude of the matrix, or what will be the outcome of this, or what is that one number that represents this in entirety. So without going into much complex definition of it, you can simply assume that depending on what is the determinant, it tells you certain behavior of a matrix, or the magnitude of the matrix. Don't quote me saying that, okay, Mr. Birendra Kumar had told you the determinant of a matrix gives the magnitude. In simple terms, the way everybody understands is, a determinant is nothing but a scalar quantity that represents a matrix. Okay, there is no formal definition as such. But if you are looking at a 2 by 2 matrix, a determinant of a matrix is nothing but, here if I have to find out determinant of A, I'll say A determinant, and that will be equal to this multiplied by this minus this multiplied by this. So now let's say if I'm talking about a 2 by 2 matrix, let's say this is 4, let's say this is 4, 8, 6, 7. Okay. Now if I say what is the determinant of this matrix, 2 by 2 matrix, it will be 4 times 8 minus this times this. So 4 times 8 is 32, minus 6 times 7 is 42. This gives you minus 10. This is the determinant of the matrix. There are certain properties associated with that we'll talk about, but for now, here you see that it's a negative value. Dhanushri, I can hear you sing very well. Okay, so here, coming back to this one. So that's the lighter part, Dhanushri, don't feel bad about it. Music is a very, very much an integral part of our life, right? So I love singing too. I'll not sing it just to make sure that I'm mindful of your time, but yeah, singing is no crime. I love that. Coming back to this one. If I'm talking about determinant of a 2 by 2 matrix, this is how you determine this. So when you see a negative value, it means something. When you see a 0, it means something. When you see a value greater than 0 or greater than 0, it means something. And I'm still not opening up my cards. I'm still holding it with me. I'm not talking about it right now, okay? I'm just saying, how do you find out the determinant of a matrix? And determinant is nothing but one scalar quantity that represents the matrix. Is that okay to digest so far? Is everybody with me? Dhanushree, Dev, Chris, everybody?
Yes, sir.
Okay. So, this is how you find out determinant. Let's keep this information parked for now. Now comes inverse of a matrix. So we have learned about identity matrix. We learned about zero matrix. We learned about the determinant of a matrix just now. Now, inverse of a matrix. What is inverse of a matrix? Let's forget about this old man teaching you guys right now. If I'm talking about, if you ever talk about inverse of something, what does it mean to you? In English terms, keep math aside for a little bit. What does inverse mean to us? Dhanushree, Dev, Chris, anybody? And give me a very simple definition.
Like the opposite?
Opposite, okay? Opposite, okay? That's one definition. Dev or Chris, any point of view?
Yeah, inverse would probably just be like opposite.
Yeah. So, as you would have seen, right? This is A. Inverse of A will be 1 by A. That is what we talk about, right? If I am talking about 5 to the power 2, the inverse of that will be 5 to the power minus 2, because this becomes 1 by 5 to the power 2. Yeah. So this is how you relate inverse, right? Now in matrix term, what would it mean to us? That remains little questionable. So if I have a, let's say, 2 by 2 matrix, 1, 5, 2, 9, what would be the inverse of this? Any weird thought? See guys, I'm not trying to put any of you on the spot. I'm just trying to see how creative you can be. Because when I was your age, I don't think I had any clue about what an inverse of a matrix would be. So I'm just trying to see, with time passing by, with the generations evolving, how you guys imagine. I mean, we know that, okay, inverse of A is 1 by A. What would be the case with the matrix? No idea? You guys are very much afraid of making mistakes. Should not be. Alright. So, inverse of matrix. Now let's relate to the concept. If I talk about A and inverse of A, and I multiply them, what do I get? 1. X and inverse of X. If I multiply them, what do I get? 1. Yeah? Now? Yes or no? When I multiply anything with its inverse, what I'm getting is 1, right? That's a very simple interpretation of inverse, right? With respect to algebra or whatever we know with respect to maths, correct? And somebody has to acknowledge, otherwise I'll be more confused than you guys. If it's not clear, I can repeat, that's okay. Chris or Dev, Dhanushree, this part is okay, right?
Yes, sir.
Okay. So, in matrix terms, what it means is this. If I have, let's say, a matrix A, and I'm not talking about the dimension right now, I'm just saying a matrix. It could be a 1 by 1 matrix, 2 by 2 matrix, 4 by 4 matrix, 3 by 9 matrix, doesn't matter. If I have a matrix A, and I multiply that with the inverse of matrix. Okay, I'm just representing it like to the power minus 1. If I have matrix A, if I multiply that with the inverse of the matrix, what I will get is nothing but, not 1, but I will get an I. Now you will say, what is I? I is nothing but your identity matrix. Now, just to help you refresh your memory, when we talked about identity matrix, we talked about the fact that if I have an identity matrix, if I multiply that with a matrix, any matrix A, I get A. That's the uniqueness of the identity matrix. An identity matrix can be of any dimension relating to the matrix that you're talking about. Let's say if I'm talking about A being a 2 by 2 matrix, then my I would be also a 2 by 2 matrix, and it will be like where 1 is in the along the diagonal, everything else is 0. Okay, so here it says, now if you look at this, let's say I'm assuming that A is my 2 by 2 matrix. So multiplication of A and inverse of A would give me a 2 by 2 matrix, and it pretty much relates to this thing, right? If you look at this, A into 1 by A gives me 1. Here it doesn't give me 1, because when you're multiplying a matrix, you don't get a scalar value, you get a matrix, right? When you're multiplying two matrices, you get a matrix as an outcome. So that's why we cannot say that, okay, if I'm multiplying a matrix with the inverse of the matrix, I'll get a scalar quantity. No, but you'll get something similar to this, and that something would be nothing but the identity matrix. Is this getting more and more confusing? Chris, you have been very quiet today. So let me repeat this one more time. So when we talk about inverse of any number, any variable, if I am talking about inverse of A, that is nothing but this. When I multiply this number with its inverse, I get a 1. The similar formula applies when you multiply inverse of a matrix. And so far we have not even talked about how do I find the inverse of a matrix. Okay, I'm just assuming that when I'm finding the inverse of a matrix, I'll have another matrix. When I multiply these two matrices, meaning the matrix itself and the inverse of it, I'll get an identity matrix. Is this part clear?
Yes, sir.
Okay. Dave, are you clear with that?
Yes, sir.
So let's do a double click on this, okay? Before we try going any further. So if I'm talking about a matrix, let's say 1, 2. It's a 1 by 2 matrix, 1 row, 2 columns. So let's assume A inverse is something. I don't know what that is exactly for now. Let's say it is something. Let's say X, Y. Okay. So what matrix definition of inverse matrix says is that when you multiply A with A inverse, you will get an identity matrix, again whose dimension will match with this guy. So like we have learned, right? If you multiply a matrix which is this is 1 by 2, and inverse is also 1 by 2. These are the dimensions I'm talking about. So when I'm multiplying A with minus A with inverse of A, what I will get is 1 into 2 into it has to be a 2 by 1 matrix. Then only I can multiply. Okay? Because we know first thumb rule is your number column of the first one has to match with this one. So see, there's one thing that we're decoding based on what we know from a multiplication matrix, right? Your number of columns of the first one should match with the number of rows of the second one. Then only you'll be able to multiply. So when I'm multiplying it, what will I get is 1 by 1 metric, meaning I'll probably get something like this. Okay. So and this is still an entry metric. If I were to multiply, let's say my metric A was 3 by 2 metric, then my A inverse will have the dimension of 3 by 2 into 2 by 3. That's the minimum I can think of. That is how these two will get nullified, and my multiplication will become an identity metric which will have 3 by 3 dimension. These two get nullified, 3 by 3, and then my identity metric will look like this: 1, 2, 3. 3 rows, 3 columns. So we are just doing a recap of how do you do multiplication of metrics, right? So I mean, so far I have not told you guys, right, what will be the inverse of a metric, right? So I'm just saying that, just going by the simple understanding of how you multiply matrices, you cannot multiply 1 by 2 metric with a 1 by 2 metric. These two have to match. So it has to be something like this. So but for the from a starting point perspective, let's pick a case where you don't really have to grapple with the complexities too much for now. I mean, you can certainly have different dimensions of metric, but for the sake of simplicity, for the sake of simplicity of calculation, let's deal with a 2 by 2 metric for now, and that is what even this whole syllabus covers for you guys. So let's look at a 2 by 2 metric. If I have A as a metric 2 by 2, which is 2, 4, 3, 9. So my inverse will have some dimension. This is 2 by 2. So my inverse have to have 2 rows for sure. And how many columns I will have, that I can decide. So let's keep it same as this one. So that way it becomes 2 by 2 metric. So from the definition we know that A multiplied by the inverse of the metric gives me an identity metric. Now here in this case my identity metric will have this dimension. So this will be also a 2 by 2, and it will be like this. So in identity metric, your 1 always traverses in the diagonal direction. So if you have 2 by 2, this one and this one. If you have 3 by 3, then this will be 0, this will be 0, and 1 will be in the third place. First row, first place; second row, second place; third row, third place. And depending on how big your identity metric gets, your position of A will keep on changing in that row. But every row will have only one A. That's your identity metric. Is it quite loaded so far or complicated? Dhanushree, you're saying something.
It made sense. Like, I understand.
Okay, so let's keep it simple for now. We have one understanding that if I have a metric A and if I multiply that with inverse of the metric A, I will get an identity metric. And what will be the dimension of identity metric will be derived based on what are the dimensions of your your original metric and the inverse of it. And so far I'm saying what are the dimensions of A and inverse of A. I'm still not disclosing to you guys how exactly this guy is taking birth. We don't know yet, right? But let's go with this understanding for now, that if I have a metric A, if I multiply that with the inverse of it, it gives me an identity metric. And we'll decode all this one by one. So let's look at this situation. Let's say if I'm talking about a metric 2, 4, 3, 7, let's say. This is my metric A. And I don't know what is the inverse of A. How do I find it out? So there's another formula that helps you find it out. So that's why we learn about the determinant of A. There's one more mechanical term that will come across, which is called adjoint or adjoint. I keep forgetting the term, but inverse of any matrix is nothing but 1 by the determinant of A multiplied by, let's say it's ADJ. That is how you find out the inverse. Like you say you have A, inverse of A will be 1 by A. Similarly, this is a mechanical formula that we have, which says how do you find inverse of a metric A. And this is more like a shortcut, okay? We'll come back to this one again. So if I have a metric A, inverse of that will be 1 by determinant of A multiplied by, let's say, let me find out how do you pronounce it. Is it called? It's called adjugate or adjoint. Yeah. It's called adjugate or adjoint. Let's say adjoint. That sounds little easy to remember. Okay. So inverse of a matrix is nothing but it's equal to 1 by determinant of A multiplied by adjoint of A. Now let's look at, we learned how do you find the determinant. So if you have this matrix, determinant is this time this minus this time this. So in this case, my determinant is 2 times 7, 14 minus 4 times 3. So 2 times 7 minus 4 times 3, which is 12. So this becomes 14 minus 12, that is 2. Determinant we got as 2. And what is adjoint? Adjoint of a metric is again a metric of the same dimension, and it will be, what happens is these two get swapped. 2 and 7 get swapped. So let's say this is A, this is B, this is C, and this is D. You will swap these two positions. So 7 from here goes to the top, 2 comes to the 4th place. This is 1. And then whatever you have in these two places, that remains in its own place, just that it gets multiplied by minus 1. So this becomes minus 4 and this becomes minus 3. So now you must be thinking that why today's class is so very different, where Mr. Teacher used to teach us how the formula is derived, and today he is kind of forcing these formulas on us. So this is more of a calculation or a mechanical way to define this. Adjoint was a term defined for calculation purpose. That's why I'm not trying to prove that. But we'll try deriving some interpretation out of it. So let's come back to what we know from this metric and what is the definition of these terms and how do we calculate that. So if, let's say, going back to the same thing, if I have a metric, let's say 1, 2, 2, 9, okay. So my determinant of this metric would be this time this minus this time this. So 1 times 9 minus this time this, 2 times 2. So this becomes 5. So we got the determinant. The adjoint of this metric would be a metric with the same dimension. We will just swap these two positions. And again, don't visualize this in terms of a 3-dimensional metric, because life will get a lot more complicated and you're not going to come across a 3-dimensional metric at least till you reach college. Okay, so let's not rush for it. I mean, you might come across that when we learn calculus, but not here in pre-calculus stage. So let's keep it simple. We're talking about 2 by 2 metric. So here these two get swapped. So 9 goes to the top, 1 comes here. And these two positions remain as is. Just that you multiply that with a -1. So this is adjoint of a metric, this is determinant of a metric. Is this part clear so far? Dave, Dhanushri?
Yes, sir.
Okay. So now coming back to the inverse of the metric. Inverse of a metric is nothing but 1 over determinant of the metric multiplied by adjoint of a metric. Now you have both the things here. So what that would mean is 1 divided by determinant of the metric, which is nothing but 5, multiplied by the adjoint. Adjoint is this one. So you'll put this as 9 minus 2 minus 2, 1. This became your inverse. Now it's like you are multiplying scalar with a metric. So this will be as good as 1 by 5. You will multiply with each and every term. So 1 by 5 into 9, that becomes 9 by 5. Minus 2 by 5. Minus 2 into 1 by 5. So minus 2 by 5 again. And this is 1 by 5. So you got the inverse. So now let's look at what is happening interesting here. This was my metric, and the inverse of that we got as 9 by 5 minus 2 by 5 minus 2 by 5 1 by 5. Okay. So what I was talking about was that when you multiply the metric with its inverse, you get an identity metric. Forget about whatever I was saying. You just know there is something called identity metric, which deals with in terms of 0 and 1. 1, 0, 0, 1. If it's a 3 by 3, that is how the layout changes. But let's not worry about this for now. What we're trying to do is multiply a metric with its inverse. So A into the inverse of this. So we are talking about 1, 2, 2, 9. This is A, and multiply that with 9 by 5. Let me put numbers. 9 by 5 will be 1.8. 2 by 5 will be minus 0.4. Minus 0.4. 1 by 5 will be 0.2. I'm just to create some real estate here. Now this is a metric. Now we know how the multiplication of metrics work, right? I have two metrics. One is here, one is here. This is A, this is A inverse. So when we multiply this, we go row, column, row, column, row, column, row, column. So first thing first, this row and this column. So 1 into 1.8, that is 1.8, plus 2 into 0.4. So that will be 2 into minus 0.4, that is going to be minus 0.8. Okay, this is my first term. Then row, column. So this will be my second term. So second value in the first row and this column. 1 into minus 0.4 will be minus 0.4 plus 2 into 0.2 will be plus 0.4. This is my first row, second column. Now if I go to the second row, first column. So 2 into 1.8 is 3.6 and 9 into 0.4 minus 0.4, that gives me 3.6. There is something cooking up here if you are paying attention. This and this, second row, second column. 2 into 0.4 gives you 2 into minus 0.4 gives you minus 0.8, and 9 into 0.2 gives you plus 1.8. If you look at this one is minus 1.8 plus 0.8. Is it? Oh, sorry, 1.8 minus 0.8. the first term became 1. Minus 0.4 plus 0.4 became 0. 3.6 minus 3.6 became 0. Minus 0.8 plus 1.8 became 1. Isn't this identity metric? Last 20 minutes of torture has resulted into an identity metric for you guys. I hope I was not torturing you, but still, if it was, this is the outcome. Is it making sense? So if you look at the sequence of events, what did I do? Nothing. I had a metric, 2 by 2 metric. I found out the inverse of the metric. And inverse of the metric is nothing but, it is derived by the formula 1 by determinant of A multiplied by the adjoint of the metric. Determinant you find by multiplying these two minus these two, and adjoint you find by swapping these two and flipping the sign of these two. That will become your adjoint. So this adjoint is nothing but another flavor of the same metric, and determinant is how you find these, multiplying these two, subtracting the multiplication of these two. Yep. And once we found that, we were doing simple multiplication of metric and its inverse to see what is the outcome that we get, and eventually we found an identity metric. Clear, not clear?
It's clear, sir.
Clear? I want you guys to get your hands dirty. It's not only me whose hands are supposed to be dirty. You guys can see physically how dirty my hands are right now. So I want you guys to get your hands dirty as well. Let's play with this. Because this will be your base. See here, if you solve one problem, okay, if I say I have a metric 4, 3, 9, 2. So 2 by 2 metric. Find out the value of A into A inverse. 2 months down the line, once you guys have practiced this enough, you will not do any calculation. You'll say, okay, you're talking about 2 by 2 metric. My answer is this. Nothing but an identity metric. But how did we get to that? That's what I want you guys to see and then believe. Because you will, while doing this, you will be able to do a recap of what you know with respect to metric multiplication. Then how do you find determinant? How do you find the adjoint? And then apply the concept of inverse and this multiplication. So this is like a bundled concept of the entire chapter to some extent. Do you guys want to try that? Chris, Tanushree, Dev. And I want you guys to try because if you guys struggle or if you guys get stuck somewhere, at least I would know that there's something that needs my attention. Okay? So give it a shot. Don't be afraid of not being able to do it. Just tell me honestly that, okay, sir, I got stuck here. Let's say Dhanushri got stuck somewhere. That doesn't matter to Chris. If Chris got stuck somewhere, that doesn't really matter to Dave. You guys are pretty much individuals when it comes to solving problems. Okay, so don't even think, okay, what my friends will think. Okay, I want you guys to think what your teacher will think with respect to what you guys have understood versus not. So this is a problem right in front of you. I want you guys to solve it, and I know you are answering with this only, but I want you guys to try it and tell me if you were able to get to this answer or not. Is that a good deal? And if you get stuck somewhere, say, okay, sir, I started with this one, I forgot how do you find the determinant. That's okay, I'll explain that. That's okay. So get started, okay? Can you guys try? Dhanushri, Chris and Dev?
Yes, sir.
Okay. Try, see again, I want you guys to try and tell me where you're getting stuck. And that's perfectly fine. I'm okay telling it one more time, because if I do it one more time, you guys will be very confident that yes, I can do it. But then when you are doing it yourself, that is when you will know at what point you had a problem to deal with. I want to get that information from you guys first. Next class, there's only one more class left for this particular unit, where we'll talk about how do you use this knowledge for solving the system of equations, and that will be it about this particular unit. Then we can go on to the next one. Okay, so one more class, you guys will be fine. Okay, so I'm giving you guys 5 minutes. I'll not keep on staring the screen to intimidate you guys. I'll just hide myself. I'll let you guys finish this. Just 5 minutes. If you guys are able to do it versus not able to do it, I'll anyways do it one more time in front of you, but I want you guys to try. Okay? Are you able to progress? Dave, Chris, Tanushree? Okay. I'll probably give 2 more minutes. Okay, how far you guys were able to progress? And just be honest, it's perfectly fine. Okay, guys, today you're learning it for the first time. I'm assuming you're not encountered this before. So first time we don't do things right always. It's okay. I failed 3 times in my driving test. 4th time is when I succeeded, and that's okay. And driving test is much easier compared to the kind of math we're trying to solve. So let me ask one by one. So Dhanushri, how far you were able to go? What all you could find?
I was a little confused.
Okay. So from where did you start? I mean, what did you start? I'm just trying to get a sense. Okay. Don't consider I'm trying to put anybody on the spot. What all you started?
I started the multiplication thing, like where you do like the 4 times, like the columns and the rows.
Okay. Let's see what you started, Chris. How far you could go?
I was just like to find the inverse. I was just like starting to like swap some of the elements.
Okay. How about you, Dave?
So I was also just swapping the elements. I didn't get really far. I got a little confused as well.
Okay. So now, okay, let me do it in the simplest possible form now. Okay. What is that we are trying to get here? We are trying to find out the inverse of the matrix. This matrix. I have matrix A. I have to find out the inverse of that, and then I'll try multiplying it. Now, how do I find out the inverse of metric? That is when I was saying that inverse of a metric, there is a formula for it which says find out the determinant. Find out the determinant. What am I writing? I'm really getting too old. Age is getting on me now. Find out the determinant, inverse of the determinant. I mean, not inverse, 1 by what, or inverse of determinant, whatever you call it. And I have to multiply that with adjoint of the metric. So I need to find out the determinant and adjoint. How do I find the determinant? Multiply diagonally, meaning you start from here, multiply with this guy minus multiplication of this guy. So my determinant will be nothing but 4 times 9, that is 36, minus 2 times 3, that is 6. My determinant is 30. Okay? So I found the determinant part. Now, what is the adjoint? We know that adjoint of any metric is nothing but a same dimension metric, but we swap. These two we swap. So these two positions. You always start from here, like the way we read, right? You start from here. This guy and this guy get swapped. So 9 comes in place of 4, 4 goes to the place of 9. And then what happens to these two guys? They remain in their place. Nothing happens to them. You put whatever numbers you have and then put a minus against that. Imagine if you had a minus 2 here, this would have been this into minus. That would have been plus 2. So good that we don't have a minus. So this is what we did to find out the adjoint. First is finding determinant, multiply these two, meaning multiply these two minus multiplication of these two, because the determinant and adjoint is nothing but it's a mechanical process, right? It's like if you say how do you multiply 4 by 6? You say 4 by 6, 4 into 6. Now you know the tables. You say 4 times 6 is 24. Same way, this is a mechanical process. I don't think there's any science to it that I can add on the top of what it is. This is just another property, another behavior, another way of representing, or another thing to find kind of thing. So this is how you find the adjoint. You just swap the first and fourth one and then keep these two in place, just put a negative against them. That is how you find the adjoint. Now you have found the determinant and you have found the adjoint. So it's like a scalar multiplication with the metric. Scalar to metric multiplication. So determinant is 30. So 1 by 30 multiplied by your adjoint. Adjoint is another metric, 2 by 2 metric. Yeah. So your inverse became this scalar, which is nothing but 1 by the adjoint multiplied by 1 by determinant multiplied by the adjoint of the metric. Now we are talking about. So this is what I mean by getting the hands dirty. See, physically hands are dirty. So this scalar multiplied with the metric. And we know that when we multiply a scalar with a metric, we essentially talk about multiplying this number with each and every term. So it will become 9 by 30 minus 3 by 30, again minus 2 by 30, minus 4 by 30. Yeah. So this becomes this becomes 9 by 30 will be like 3 by 10, 0.3. I'm just trying to find out some amiable numbers, right? 3 by 30 is 1 by 10. So minus 1 by 10, that is 0.1. This becomes 2 by 30, 1 by 15. This becomes something like 1 by 15. That will be how much? 1 by 15 is this. So 15, 6 are 90. We got 10.66. 0. Yeah. Or I'll round it to 0.67 or 0.7, whatever it is. And then this is 4 by 30. 1 by 15. It's again 2 by 15. So it will be like 0.14. Let's keep it 2 by 15. That's okay. Now we found we have the metric and we have the inverse of the metric. When you multiply these two, you will find the entry metric, which is, it will be 2 by 2. So 1, 0, 0, 1. That is what will come down to. I'm not doing the multiplication, but again, when you have to multiply it, you know that first when you multiply a and minus inverse of a, first element will be first row, first column multiplication addition. Second column will be first row, second column will be first row, second column. This will be second row, first column, second row, second column. So that is how we multiply. So when you multiply that, you will get that. I'm assuming that you guys have no doubt with respect to how to multiply matrices, right? That part should be clear. You just go by the English definition. First row, first column. When you are multiplying it, you are saying first row, first column. This is first row, first column. So first row and first column. So first element with this one, second element with this one, multiply them, add them together. That becomes your first row, first column. First row, second column. First row, second column. So you take these two, multiply first one with this one, second one with this one, add them together, that becomes your first row, second column. Is that part clear?
Yes, sir.
Chris, Dhanushri. So a summary of what I've done is, I have not done anything magical. I'm a very simple guy, so I'm doing a simple thing. Our objective was to have a metric, multiply that with the inverse of that. And how do you find the inverse of metric? This is the formula. 1 by determinant of the metric, multiply the adjoint of the metric. Determinant by adjoint. Sorry, determinant times adjoint. Or 1 by or adjoint by determinant, whatever way you remember it. Determinant you find by multiplying these two minus multiplication of these two subtracted from that. Adjoint you find by swapping the position for the first two, first and fourth, and putting a negative against these two. And you find the inverse of that. This becomes scalar 2, metric multiplication. Once you found that inverse, multiply these two metric. Again, we are doing one last time multiplication of this metric with the inverse of the metric, and you will get the INT metric. Yeah. I know this is little cumbersome, but it'll become easy when you probably solve. Just randomly pick any 2 by 2 metric and try solving for it. Yeah. Are you guys promising me that you'll do a few? See, this is what a daddy-like figure does. Okay, I'm a daddy-like figure for you guys, right? So I'm saying that this is what I invested for making you guys understand this. I want you to give me some return by practicing few of them. Okay, that's my motivation for explaining this to you. Now let's think through it a little bit, because there is no math without thinking. Okay, so let's keep our understanding confined to a 2 by 2 metric. Let's say I have a 2 by 2 metric, any 2 by 2 metric. I have a metric. Okay. And you guys know, if you have to find out the determinant, you will say this times this is 6, 5 times 6 is 30, minus 7 times 9 63. And I'm doing it on purpose, okay? So that's not, you see it so many times that you get tired of it and it stays in your memory, okay? So I found the determinant and I got something like 5 6 is 30, 7 9 is 63. So 30 minus 63 gives me minus 33. Okay? Now, you know that you can find out the adjoint also. And for doing the adjoint, you don't do anything magical. You just swap these two. So 6 goes in place of 5, 5 comes in the place of 6. And these two, just change the value, just add a negative against them. Or get multiplied by minus 1. Okay? And that is how you find the inverse. And once you found these two, you know that, okay, my inverse of the metric will be nothing but 1 by determinant of the metric multiplied by adjoint of the metric. Okay. So far, nothing scary, right? I'm just doing a repeat telecast of whatever I did. But I'm doing it for a reason. Okay? Why I'm repeating myself, there's a reason to it. Do you think we can find out the inverse of any and every metric? Again, let's keep it confined to 2 by 2 metric only. Do you think that in any and every circumstance we'll be able to find out the inverse of a metric? Following the same steps? Think and tell me. You have the formula in front of you, okay? I'm just trying to generalize this with some thoughtful view around it. And I'm repeating my question. Do you think that if we know that this is the way to find out the inverse of metric, we'll be able to find the inverse of any metric under any circumstances? And again, I'm limiting it to 2 by 2 for now. Can I hear a confident yes? Dave, what's going in your mind right now?
Nothing, sir. I was just thinking about this.
Okay,
It makes a little more sense now.
I'm saying you have the formula in front of you. I'm saying that I'm talking about, or I'm keeping our discussion confined to a 2 by 2 metric only for now. And this is not end of it, but I'm saying from a conceptual standpoint or from a scope standpoint, and we are keeping it limited to 2 by 2 metric. I have a 2 by 2 metric. I know how to find the determinant. I know how to find out the adjoint, the metric, and I can apply the formula to find out the inverse. And this formula will not change till my lifetime. Okay? So now my question to you guys, and I'm sure you guys will laugh at me, is that with this understanding, or whatever we have learned, or whatever we know, we'll be able to find out the inverse of any metric at any point in time. Can somebody say yes? Dhanushri? Yes. And I will say no. That was the purposeful intent of asking that question. You cannot find the inverse of each and every metric, because you will come across some situations, you might come across some situation when the inverse becomes undefined. And you know what? When that will happen? When this guy goes for a toss. If you ever have to divide 1 by 0 multiplied by adjoint of a metric, that is when you are talking about an undefined state. You are dividing 1 by 0, that itself is undefined by itself, no matter what you are trying to multiply that with. Meaning, there is a possibility where your determinant can become 0. And whenever your determinant becomes 0, you are essentially talking about a situation that you will not be able to find out the inverse of a metric. Does it make sense? Chris, Anushri?
Yes, sir.
And guys, you guys are like babies for me, okay? I treat you guys like my own kid. So, if I'm asking a question, you don't have to be shy. You don't have to feel that I'm trying to put anybody on the spot. My intent for asking question is to make you think and relate it with what we know or what we have learned, okay? That's the purpose, okay? Never get me wrong, because when I'm teaching, I'm emotionally connected with you guys and the math both, okay? This is not my baby, this is my dad. You guys are my babies, okay? So here, coming back to this one, I'm saying that we know how to find out the inverse of a metric, but there will be situations where the inverse of a metric would be undefined. And that is what we will decode in the next class. That is why when I was talking about the determinant or the adjoint, I kept something paused. I said I will not talk about what a determinant means when it is equal to 0, greater than 0 or less than 0. Now you know the merit in what I was holding on to. Determinant plays an important role to say how you can or ensures your ability to be able to determine the inverse of a metric. And again you will say, okay, why do I even care? I know how to find out the metric, how to do operations with metric and all that. And what is the role inverse is playing? This is just an extra burden on us to learn something new which doesn't seem to have a relevance. And again I will request you guys to hold that interpretation for now, because this guy is also relevant. I will not teach you guys anything which is not relevant. This guy has a role to play when we come to talk about solving a system of equation this guy will have a role to play when we come to finding a way to solve the system of equations using the inverse. So if you know how to find out the inverse, then you'll be able to solve. If we don't know how to find out the inverse and what is the implication of all the things that helps us in determining inverse, probably our approach will not be fully it will not be foolproof. Sometimes I run out of English words, but yeah, what to do? My education happened all in India. Your English is 10 times better than mine. So that's why if I struggle with any English words, you guys can help me out. So coming back to this one, how to find the inverse. There will be situation when we cannot find the inverse, and that is determined by the determinant of a metric. And that's why it's called determinant, because it helps you determine something. If you guys recall your concepts around the quadratic equation, there's a quadratic formula which says you can find out the value of x, which will be minus b plus minus b square minus 4ac by 2a, right? And this b square minus 4ac is called the determinant. If this turns out to be negative, you cannot find out the square root of a negative. And Dhanushi will disagree with me. She will say that there is something called complex number. right? Imaginary number. But not going to the imaginary side of math, I'm saying that this guy determines whether you'll be able to find out the solution for x or not. And this is called determinant, right? Similarly, here in the case of a metric, when you say determinant, we are essentially talking about something that helps you determine the outcome of a certain set of events. So that's the reason why I was pestering you guys with sharing your understanding of what is a determinant. Now I think we can connect the dots. Yeah?
Yes, sir.
Okay. So here, whatever we have learned, that will help us to get to the final stage or the finish line of this chapter or this unit. It's almost time, so I'll not drag it further. I will let you guys go. Enjoy the rest of your evening. Have a good dinner, good night's sleep. Don't think too much about math, and if you think, only think to relate. Okay? And when we come to the next class, we will decode or find out the connecting points between the system of equation and the matrices that we have been talking about. Alright? With that, I'll let you guys go. Enjoy your evening. See you guys coming weekend.
Bye, sir.
Thank you, sir.
Alright, bye-bye. Bye-bye.